Hello to anyone watching. Time for me to finally wrap up day 9's challenge. I have a way that I think should solve it. I'm going to implement that. If it's either too slow or doesn't work, that'll be the end. Or at least for day 9, and I'll just move on. Because honestly, I don't want to bash my head into this more than I've already done. So, just as a quick refresher on what the challenge was for day 9. This refresher is for me as much as it's for you. Right, part 2. I am given effectively corners of a very, very large tile pattern. I have to find the largest rectangle that two of those corners can make, fully inside of the shape it outlines. I have found a way that should allow me to very easily detect, like relatively easily detect, if a rectangle ever falls outside of the shape. Might not be the most efficient. Basically this rectangle in shape function is basically going to write a raycasting function. If at any point, a line intersects, which I've already written yesterday, if at any point intersects one of the other lines, it's outside the box. And I forgot again. This is the line intersects function. Funny mathematic tricks. If at any point the line, like these two will form the corners of a rectangle. If at any point the lines of the rectangle intersects any of the lines in tiles, then I can just return early. Which means this has to be true, actually. And this is just going to be a loop. For now, I'll need to construct the 4 lines of the box. Line from tiles. Not gonna be anyone from T1 to T2. Let's say I start T1 as a start point and tile. What I'm going to do here is go for T2.x and T1.y. Can I get away with that? I sure can. From tiles, we'll go from this to T2. Another from tiles where I go from T2 to come on. This one will go from first I move from T1 towards T2's X value. Then I move from there to T2. Now it's once again to the X value, so T2.x to T1.x and T2's Y. And then one final one going from here back to T1. That will be the 4 lines of the rectangle. And now we can just actually need to call this line box line. If line dot intersects with Let's. This can be line from tiles. Starts to tiles at end. For convenience, I can swap those. That should do it, actually. That's a rectangular shape function. Now the annoying thing. How do I want to check this? Actually, let's first, for starters, working on the test inputs, which if I pull up the challenge, I guess I can just test it with this example or any of these. 7.3.11.1, which are 2 and index 1 and index 7. So inserts rectangular shape. That's not good. What did I mess up? Hide that again. You get the right ones, right? And 3. This is 11.1, so those are correct ones, and that is a problem. So in that case, those are indeed 7.3.11.1. From 7.3 to 7.3 to 7.3 to 11.3, then from 11.3 to 11.1. Correct. Then from 11.1 to 7.1, and 7.1 to 7. Let's check out. So which ones seemingly intersects? Line from 11.1 to 11.7. That shouldn't be. Did I mess up the definition here? Which line does the intersecting here? 11.3, 11.3. Huh. So check out. It touches, but it shouldn't. Does touching count as intersects? That would be the issue. That's it. I think I know what's causing that, which I thought was a bug last time, but seemingly caused the issue. Touching doesn't count as an intersect for this, so make those stricter last time. Doesn't that work? Works. Question, is that just because... hide that again, but not really. This time it did work. Question is, did that work because now it connects, now it does too much, or does it just work? Because I want to try. So yeah, that is going to be an issue, because I don't think this will be detected. It won't detect this as being outside, which is an issue. Like if I try to draw a box between, what's that? 3, 3 and 7, 1? Or something 1? 7, 1 and 2, 3, I guess. That'll be indices 0 and 6. I think this will not work, which is bad. Because it's not. Which means my algorithm doesn't work, which is a problem. Because now it detects this as in the box, which it's not. Because it's only lines that are... it does go outside, but... yeah, that is indeed a problem. I didn't account for that. I don't know how I fixed that, even. So what I wrote should detect something like these two. That will be detected. That will be 2, 3, 2, 3, 2. One of the high ones, 11, 7. Next 60, next 2. This one will fail. It won't fail, that's even worse. Starting with these indices, this should fail in its entirety. It doesn't, which means it's just completely broken. Well then. If that method doesn't work, then I might just be screwed. I know the raycast method works for determining if any point lies outside, but these rectangles are too big to try every point inside of them. Is it because of this parallel lines check? No, it's not. That means this method does not work. Well then. In that case, I don't know what I can do. That means this part doesn't work correctly. Besides, what I was thinking, the whole intersect idea doesn't work because of these edges. Like, on this, since it's inside edges, this is fine. But this ends up being an outside edge, which is not. Because of how it's designed, though, I don't have to check every point in a box, though. I can just check every point along the 4 edges, which sucks, but I could do it. Which, first of all, I need a stricter intersects function, which actually works. does require rewriting this. Each of these lines. Needs to be at the start, of course. Now I'll have to check every point on here to see if it intersects with lines. Gotta be careful with how I count intersections though. That's the tricky part. Because if I pull this up, like for example going from here all the way through here, it should count this as an intersect and the... hold on. This should count as an intersect, this should not. I can freely pass through a corner. Can't pass through the center of a line. This will be critical, I think. Same here, because if we have a point here, it can't pass through this corner because it runs along the line. This counts as an intersect if you... This counts as an intersect and this counts as an intersect. If I start here, and this counts, but this is inside. Ah! This is a serious issue. I think what I really need is to have the bounding boxes for this be one outside each time. Things, how do you define that? If I get the bounding box to be this surrounding area, it'd be easy to check. Then I would need to define that correctly, which it really is a pain. Oh no, how do I deal with that? I would need the... It seems like the type of thing I would need to do when parsing, but how? Do I want to bother trying to implement this right now? Kind of have to if I want to complete this. Do I wanna? This thing, this I could have it like this, where this counts as an intersect with this edge. Doesn't count with that because it runs along. You would again have the problem if I run over the top here, as it intersects as long as the line is, which is not good. I guess running parallel doesn't count as intersecting, but running into it does. I think that would also mean that this counts, which it can't. The way I deal with that's only checking the outside lines, but that's... Yeah, I'm gonna have to redefine my shapes here, but that's gonna stink. But I'll have is do have a guaranteed binding order, because that is important here. Unfortunately, the order matters. Input. Let's see, here it goes. First it moves positive X direction. Here it moves positive Y direction first. So here it moves positive X, positive Y. So this is binding clockwise. This one is also going clockwise, I think. So that is good. Knowing that both on clockwise order does help a lot, actually. Outline is instead going to be a box of line. Here I can have a button generate outline from takes line. It makes a box size line. I could do something to detect order as well, but I'm not going to. It's fine. Okay. Since these are the number of corners, and there's... How many lines are there? So you have just 4 of them, you get 4 lines, adding a... Always going to have an even number of corners, aren't you? 1, 2, 3, 4... 5... You can have an odd number. One, 2, 3, 4. It does always close, and I think the number of edges is equal to the number of corners, so I can vec with capacity. And it does make sense because I'm creating. Yeah. Thing is, here I need to make sure that I actually push this line out to the correct side, because this is going to be the line just outside the shape. Which is kind of annoying. How do I do that? think I need to detect the direction this is going in. Of course, all this needs to be mutable. Otherwise, it's not a very useful function, is it? As we know it's clockwise, a line going in a certain direction will always have its outline. Outline will always be to the left of a line in clockwise order. Yes. I can use Signum for this, because it's always going to be the +1, -1, or +0. Going from T2 to T1 to T2, so it's going to be x2 minus line.x1. Need to be I64s for this to work. Doesn't need to be divided. You can just do Signum. If it's 0, then x doesn't get offset because that means both are on the same x position. If it is moving along x, so it's going from left to right, that means that it's going to be higher x minus 4x positive. Going on the x direction, which means the x needs to be minus this. So I need to invert these because yeah, this does need to be offsets like this. Is this one's a difference, and going from, say from the example, it goes from here to here. It's going to be a positive number, but the y position. Wait. If it moves on the x direction, it needs to be -1 in the y. Moves on the y direction, needs to be positive x direction means -1 in the y, negative x direction is +1 in y, positive in y means positive x, negative in y means negative x. Positive in I should have shown that. I think this is correct. Positive x means negative y. Yeah. I can do push. Now I need to implement that. Here, line. Ta-da! I think that should do it. I can do I'm just going. Oh, sorry. I'm gonna do the same as always. X going to be height. That still works. Now I just need to set. Do I want to do this fancy and actually draw nice lines? Yeah, I can. So that sets the corners, and I'll want the direction. Or at least I need to know if it moves X or moves Y. So also this of course needs to be X1 and X with 2s. So same X means it's a, this is so for a vertical line I can This will be from or Y in I'm not even going to care about deduplication here. For Y in I can do something nicer here. First one's going to be the min of this will mean it always runs in the same direction, but this needs to be +1. Because need to skip the first value. And this will need to be... Yeah, that's already fine because it's already exclusive range. Yeah, and then I can just grid at it times y. No. This one needs to be a dash because it's vertical, so it needs to be a pipe symbol. This will need to be X. This does need to be dashes. Does this print the shape correctly? Not quite. Actually, it almost does. Because of this being wrong. Oh, wait. I need to pull up this to go with it. So this top line is correct. Yes. 2, 3, 4. This one's also correct, actually. This line's correct. This one is not, I don't think. Why are you wrong? This one's right. Why is that one wrong? Because it's an internal corner that cuts it out. That line wouldn't... The mistake is these lines. They would need to be cut short. How do I do that? So it's whenever there's a... I think I need to cut the line short anytime there's a left-handed turn. It needs to be cut short at the end. How do you determine if it turns left-handed though? That is a problem. Print function works, it just means my outlines are wrong. It's kind of a pain because that means I need to change this. So basically, I have the direction, I just need to find out which way. From the line alone, I can't know if it's a left-handed turn. We only need 3 of them for this. That's... How do we do that nicely? That's what I need. Next is +1 mod. Almost done. So for right-hand turns, this line, if the vertex at the, I need to be careful with this, because if the vertex at the end of a line is a left-handed turn, how does, first of all, if it's a left-handed turn, that means I need to move X back 1 in the direction of the line. So I can rename these. Direction Y is let's see. Okay, how do I deal with this now? Also, I need to hide this again. Damn it. So I have the directions figured out, but that's... Vertex is... What I need to do here is find out if if the line from end to next, I need to find out that that line makes a left-hand turn compared to this, because going from here to here is straight, and this will be a turn to the right in the direction of the line. Same here, this will be right in the direction of the line. But here, since in the left of the direction of the line, I need to cut it short by 1. Thing is, how do I want to do that? And cutting short is going to be +1 or -1 of the offset. I'm gonna have offset X is going to be offset X equals. Issue is it's only on the end of the line, not the start, which does make this trickier. Ah. I need a quick break. I'll figure this out in a bit. Back in just a sec. I'm back. Let's see. So I need to get an additional offset for the start and end here, because if end and next form a left-hand turn, I need to make that line one shorter. Actually, this one also needs to be one shorter, so if... Oh hell, how do I need to do that? Because currently I'm checking 3 vertices, so here, here, here. Here, here, and here. How do I track nicely if I was doing a left-hand turn? Because I'm now realizing coming out of a left-hand turn also needs to be shortened up by... not just by 1, by 2. Pull up the example. Where is... let's figure out this corner over here. Because that is... here is a corner. This isn't the corner, so both of these need to be shorted up by 1. So that means 2 lines need to be shortened up. You track that nicely. So to assemble a line, I really need to look at 4 different coordinates, which is kind of rather pain in the ass. I'm gonna assume this works. It won't work on 2 short input, but... all of these will now just same mod corners length, not and. It's definitely modulus. Oh, I need to change all the offsets. Okay, this is going to be a little bit tricky. Actually, let's split this up. So for the start, I need to determine if from previous start and end forms a left-hand turn. And then dependent on direction, I need to add 1 or subtract 1. For example, let's say I'm going here. Let's say these are starts and let me start first. Let's say this is start and this is end. And this is previous, so I need to check a previous start and end, form a left-hand turn. So I need to find the direction from previous to start. That's going to be oh wait, this needs to be and this needs to be corners at proof.x as I64. These need to not be references, and I can do the same for the y direction. So from this I can determine if a line is going vertical. Okay, so again, taking this as an example, previous starts end next. Previous start will be found to go no change in x and negative change in y. So if dy is less than 0, show that here. Previous to start is negative y, so start end. That's correct, isn't it? Because this to this is negative x. The other way around, then this were previous start end. Previous to start is positive x. Left hand would be negative y, but instead it's positive y, so it's fine. So that's for the line, but not for start and end. No, it is for start and end, because direction x and direction y are from that. So if x less than 0 returns, and for the example, start to end. This start to end is previous. This means this line would go from here to here, but then moving negative x, this means the start needs to be x minus 1, so minus 1, 0. Else be 0, 0. Else if this is 0 and so in this case, that means that previous start is positive y, which means it's the exact opposite of last time. Instead of going from here to here into a left turn, expecting it to go from here to here, this will be positive y. If this had turned left instead, that means, yeah, positive x is now a left turn. Similarly, it's greater than 0. And let's say here returning x. This is previous to start, and end will be somewhere over here. End will be somewhere off here. That means that doesn't need x would go here, but x needs to be plus 1. Yes. So this is going to be positive 1. Similarly, else if ref start dx is less than 0. Previous to start is negative x. Left turn means. Gotta make sure I get this right. I'm once again forgetting to show the code, but I'll do it in a sec. So we're going negative x. Say this is previous and start, and fictitious end is somewhere over here. So it means if it goes from negative x to positive y, that's a left hand turn. So if direction y greater than 0, making sure I do this right. This case, previous start. Measuring from start to end. Would correctly place it here, but that needs to be y plus 1. So else 0, 0. Similarly, else if rev start the x greater than 0 and less than 0, it's going to be inverse, so 0, negative 1, else 0, 0. This shouldn't happen, but it's safe to do anyways. Now, unfortunately, I need to repeat all this logic, but to repeat this logic for end, which means start is going to be end next. Direction X, Y, this is going to be question is, are offsets still correct? And once again, forget to show code. Shitload of checks. Question is the offset still the same if I'm doing it this way? So here I'm just going to say previous start end next. I'll say previous start end next. So in this case, the end needs to be pulled back one, so start to end is negative y. Negative y direction. Then it needs to be y negative 1. Or y positive 1. This is different. Because in this case, it doesn't need to go to negative x. Directions are different. Because this needs to be 0, 1. Similarly, this will be into 0, negative 1. Because in this case, I'm shortening the line differently. Because here we're going start end to next. This is a left turn. This line needs to be pulled back, so it's positive y. Something the other way around would be negative y. The x direction case here starts end next. Instead it goes positive x means negative x. That's still the same, isn't it? Negative y, so plus 1. If we're going positive x and minus 1 on x. So this is the same direction with flipped comma. No, these are not duplicate code fragments. Not really anyways. That should work. Question is, does it work? Or is the more likely case that you're gonna panic? Why is it endless looping? Because end shouldn't be modulo, that's why. Oh, that almost worked actually. Not quite right, but... Okay, so that one adjusted... This line adjusted correctly. Oh, also didn't. The coordinates are shrunk in right. It still doesn't quite work. It comes close though. So I can just debug start values. Just debug all these. It's always 0. That's not a good sign. That means my coordinate section is broken. Well, at least we know what's wrong. Because we know the inputs, I can look at this. Go to here. 712. Where I actually start is here. I go 73 to 71. Should detect that this is coming out of a left-hand turn. So the first one should already be hitting that. It should be literally on the first one. Should end up here. Okay, am I seeing this right? Is this correct? Going from... I'm going from... Previous start is 6 to 7, so that's the last ones. 2, 3, 7, 3, which is... Here to... I'm going to be here to here. Currently I'm figuring out this line, apparently. Start is 7, 3, and it's going to 7, 1. Figuring out this line, which is indeed after a left-hand turn. 3 and 7, 1, so it should find that 6 to 7. Previous start is positive X, and this is indeed negative Y. Does help to name things correctly. This part is correct. This does need to be swapped like this. Oh. Hold on just a second. I think it's correct. So directions were swapped. Is that correct? Holy shit, I think it is. Because, yeah, that's 3 long. Supposed to be 5 wide. Holy shit, it's correct. That worked. Somehow this whole mess of conditionals works, and I'm now correctly making the outline. Oh my goodness. Let's name this correctly for consistently. Start end X. Oh nice, start end. That's a group that no longer exists. Actually, let's do it entirely correctly. There's a change in X and change in Y, at least the direction of it. Okay, the outline code works. Don't touch it ever again. So the outline works. Now for... we'll have the lines, so... now the annoying thing begins. I'm going to basically attempt brute forcing this. I'm going to draw a line out from every point. Basically, from this, I'm going to cast a line out towards either positive or negative. Doesn't really matter. I'm going to walk along each line, use that as a starting point for another line, cast it out towards, let's just say 1,000,000, just a large value, and count the number of intersects. If it intersects an even number of times, it's outside the square. If it's an odd number of times, inside. At least in theory. So let's see if that theory works in practice. How do I want to do that nicely though? For each line. If outline dot so for each line and for each point on set. Ooh. I think it's easier to just let L equal this will be moving in the X direction. Ly1, Lx2, y2. Ordering doesn't really matter, so it'll have to be inclusive, I think. Does that work? This will once again need to be min-max. This way I'll make sure that I always go in positive, like go from low to high coordinates for convenience sake. This counts if a particular point is in the inside, but I need to check every single one because some of the points might be out. So let's intersections equals outline dot iter dot filter. Let the line be line. Going to be from X as far. Let's just set it to 1,000,000. This be U64 on Q size. Y1. Since the Y's are equal here, it's fine. If intersections and 1 is 0, no, it's equal to 1, because that means there's an odd number of intersections. An even number means let's hope the intersect code works correctly. I'm gonna assume that it does. Now we'll need to repeat this with the other lines. LX2 is going to be much the same. So this is going to be I think that works. Yeah. Do it again here. Oh wait, 2 instead. That works, that works. Nice. This function, as you might have guessed, is not going to be all that efficient. But the question is not, is it efficient? The question is, does it work? Insert rectangle in shape, outline, tiles at. Let me pull up one of the examples here. Should be able to find that the rectangle between 9.5 and 2.3 is in. So that would be index 6 and index 4. That's not good. So which one of you buggers panics? Doesn't show. Lovely. Which one of you returned false? It's probably an intersect function issue, realistically. Doesn't indeed go from 9523. So 252523 2393 failed on Y direction. So this should be 3, 4, and 5. No intersections because it lies fully within the shape. Oh dear. If it lies fully within the shape, it doesn't intersect at all, which means it's perfect. Just need to add checks here for equals 0. Of course, it needs to be an odd number greater than 0. Because if it never intersects, that's also fine. That works. Now, importantly, let's test for one that should fail. That would be testing. What's that? 7 7 1 7 1 and was that 2 3? That would indices 0 and 6. If I choose 0 and 6, this should panic. If it doesn't, if this doesn't panic, that's bad. God damn it. Why aren't you panicking? So I'm running from 7-1 to 2-3, which is, looking at this grid, 7-1, 2-3. Okay, so it's drawing the line. Currently testing 7. Starting at 2. Okay, this is online LX1. Only start at 2. Starts at 2-1. Which should have kept that print in here. Why did I delete that? Because it starts at 2-1, so it starts out here. Should find an intersect here and here. Why does it not? Outlines here should be. There should be an outline here from. What is that? 0, 1, 2, 3, 4, 6, 2 to 6, 1. 6, 2, 6, 1 should have one. It does. Outline 0, literally the first one. So why doesn't it intersect? Let me guess. Sneaking suspicion is my intersect function not being correct. So I'm dealing with this one, which means this is alive moving the X direction, so I don't need to check this half. So I'm checking these from 261. Let me make sure I actually understand my own checks correctly here. So, other Y1. Because equals. So moving the X direction, so any touch here is fine, and this needs to... Actually, because of how I've rewritten this, it should be fine if I make all of these equals. This does require more testing after, of course. Now that's what I want to see. Very important question though. Does this still work? We may be onto a winner after far too many hours. Might be onto a winner. Let's test another one. From here. I do need to check for these. 9.7 and 9.5. Which would be indices indices 3 and 4. Good. Gonna assume they're never equal because I didn't think about those edge cases and I don't want to bother. See if I can have another edge case here, which is 2 something high to 11 high. One counts. 2.5, sure, 2.5 to 11.7. That would be index 2 to index 5. They should panic. Holy shit, I think I have finally done it. Okay, now for the annoying part. I want to test each possible pair of rectangles to make sure I just get the largest area. Then I can do... from tiles and outline. I'll rename these to overall corner 1 and overall corner 2. This can be CC1 and CC2. Now Find largest contained. So how do I want to make sure I never check duplicates? Can I just... I have an idea. I can do this index based, and being clever with indexes helps here. For C1 in 0.tiles.len, for C2 in C1 plus 1 tiles.len. This always prevents duplicates already. Actually, I can a between returns a 264. So since I'm computing it anyways, I might as well return it. Largest indexes equal just do grab that twice and say area. Nice. That's not how you... If rectangle in shape, it's going to be outline tiles at C1, reference to tiles C1 and reference to tiles at C2. And greater than largest area. I think this should work actually. I just don't think it's going to be very fast. Does it work correctly in the test input? Almost, because that needs to be... Might want to unalive lifetimes. I do need to unalive. Luckily, these are going to be pretty easy. Also, that's funky. going to be these two. These three that are tied together. 'Cause this light doesn't have anything to do with it. Tiles at largest C1, largest C2 is 0. That'll work. Actually, this would be faster to more efficient to just store the coordinates instead. Less array indexing. So I can just do it all at the end. Strip that part out. Is that correct though? Largely 24 between 9, 5, and 2, 3. Holy shit, it works! Now, that was on a fairly small input. I'm scared. This could take a while. Release profile, please. It's not very fast, is it? I'm going to take a quick break and hope it completes in the meantime. I'll be back in a sec. So it's still running, huh? that is... I might just want to wait for this to finish, if I'm being honest. Because I don't feel like rewriting this again. The code should eventually complete, so... I think I'm just gonna leave it running. I should have included some debug statements so I could test, like, see how many comparisons there are, like how far it is, how many comparisons is done. See, I want to even implement that in. Ah, whatever. I'll trust that it finishes running eventually. For now, I don't need to touch day 9 anymore, so I think I'm gonna just move on to day 10. Because this will just keep running. If I at some point hear my CPU fan spin down, that'll be a good sign. Anyways, for now, I'll just look at day 10's challenge. Once again, I don't know what that will be. Let's just get started on this for now, because thought I heard complete but didn't. Let's see. Day 10 factory. The elves have plenty of time to decorate, but the machines are offline because of bad Niprog. Oh no. Bad doggy. Indicator light. Damn joltage again. Okay, so I need to find indicator lights, button wiring schematics, and joltage. Oh hell. Toggle the state of lights, pressing the buttons. There's no such thing as half a press, except if you're playing Super Mario 64 and are using the A button. That is an amazing reference. Oh hell. I should know how to solve this because I've done it before. However, I do not remember how to do that. You need to find the fewest total presses too. Oh no. Second machine. Oh no. Truth be told, I should know how to solve this, but I've completely forgotten the theory behind it. Which is not great. Oh, do I even want to do this right now? I can at the very least parse it in. That part's pretty easy. Going to be actually, I don't even want to rewrite it. I'm just literally going to copy paste it from here. What were they calling it in the challenge? I don't want to call this a procedure. Let's call it procedure. this can be a result something string. Each of these I can have indicators can be a... How big are these indicator arrays in the final test input? Not that big. I could just represent these as a like a fairly small unsigned number. It's always between 0 and 9. So it would seem. Why couldn't they have done between 0 and 7? Because it could have been U8. Whatever. It could be U16 and I could just use... I can use like bit masks. I can use this as a bit mask basically. Indicators, stats. And buttons can then be a slice of U16s. Because if I'm doing this bit mask ways, actually let me do it on test input, then this will only set the bit shifted 3 to the right. This will set 1 to the right and 3 to the right. This will set a bit 2 shift. This will set unshifted and 2 to the left. Because since each of these are always just an... Since these buttons are always just an index between 0 and 9, I can't just treat it as a bit mask. It's actually quite nice. Because bit masks are easy to work with. The joltage requirements are... I can just say joltages can be a... These numbers, how big do those numbers get? Yeah. U16s, why not? But this time they're not bitmap, they're not bit masks. These are just actual numbers. So each line can be let's mute. Then I can do OK procedure. This can be a boxed slice of procedures. Because this needs to be a nice. I still like that you can just collect like this. Rust is awesome. If not line that starts with line has to open opening brackets, then that line, nice. Let's find Bytex. Could do this with Bytex, but ideally wants to. Time map. Map. So I can say I could. I'd like if I could just. What I can do is. Skip one, dot take. We can dot reduce 0. Take in mask and it's not reduce, it's fold. What I can do is I've run this the opposite way. I need with indices ideally. Enumerate, that does work actually. Trick I can do. It's equal to hash, then beautiful. For indicator light 0, it doesn't shift. For indicator light 1, it shifts once. That is beautiful. It's disgusting, but it's beautiful. Could do it as bytes instead, which would be nicer. Bytes. So I can say it's slightly nicer, I guess. This part is going to be a bit more annoying. Still running. Maybe brute forcing wasn't the best approach for yesterday's day 9 challenge. Surely the runtime can't be that bad, right? I don't even really want to do this part right now. Writing parsers can be a bit of a pain. I can extract this part out. Kind of want to extract it out, but also I don't really. In fact, it's out as a method. That part is nice. Also, this really should be bytes and should be. Because it's currencies, I should do it like this. Nice, that's not done. I don't even really want to do this part, if I'm being honest. Parsing numbers is a pain. No, I want to keep going until this is done, but I don't know if I have the patience now. I'm definitely going to keep this running on my own time, but yeah. Kind of running out of steam, if I'm being honest. Because here I will need to... Kind of do it like this instead. I can do. I could even do this part differently now. If I want, instead of just reading to the end, I can read each character once. Instead do something like... Take a while. Still need to count how many items we're taking, which is kind of annoying. So I'm gonna leave things as they were. This I could extract that into parse buttons. Cars from rest onwards. That should work. This doesn't need to be mutable anymore either, because I'm going to do all that in here. This doesn't need to be interbox sliced anymore because it's already done. The same with voltages. Since this one's the last, I don't need to worry about wrapping it like this. Yeah, then I just need to write more parsing code, which I don't really want to do. Can really say +2 because of white space. I can do something similar to this. Still going. Oh, I should have done a better job at implementing this, but I just do not care anymore. That is assuming it does complete. It should, because there aren't any infinite loops anywhere, but... yeah. I think I'm gonna try and finish this some other time. It's about time I go stop for that. I need some dinner. Anyways, I'll continue this tomorrow. Hopefully at the start of the stream I can report that this is finished. But until then, see ya.